Hello pre-calculus students. Today we're going to be graphing secant and cosecant and their transformations. You'll remember that cosecant is the reciprocal of the sine function and secant is the reciprocal of the cosine function, and you'll be able to see that in their graphs when we graph these. So let's remember that on the unit circle, sine is the y value. So what we're going to do with this table of values over here is we're going to take the y value and then we're going to get the reciprocal of that y value to find the cosecant of that angle. Now you might want to take a minute here and pause the video so you can get the x values down that I've written, and then you can continue. So at x equals 0 radians, you can see that you have 0 as your sine, and the reciprocal of 0, 1 over 0, is actually undefined. So the cosecant of 0 is undefined. At pi over 6, I chose pi over 6 because the sine is 1/2, and that's an easy reciprocal. The reciprocal of 1/2 is 2. That's going to be much easier to graph than the reciprocal of root 2 over 2 or root 3 over 2, so that was just an easy choice. At pi over 2, the sine is 1. The reciprocal is 1 over 1, which is 1. And back over to 5 pi over 6 because 1/2 has an easy reciprocal, and that's going to be 2 again. And then just to make sure I get all the way around the circle, I started jumping ahead. I jumped ahead to pi. Reciprocal of 0 is undefined again. 3 pi over 2, the reciprocal of -1 is 1 over -1, which is still -1. And then back to 2 pi, which is really the same terminal side as 0, and so it's going to have the same reciprocal of 0, which is undefined for its cosecant. So the way you show undefined on the graph is with an asymptote. This asymptote says that there are no y values when the x is 0. Pi over 6, we're going to need some labels on our axes. So because this is the parent function, the fourth line is going to be 2 pi. And then this will be pi, half of pi here. So I have 1/2 pi, 2/2 pi, 3/2 pi. And then on the y-axis, I'm going to label 1 and 2, -1 and -2. So here's your cosecant. And I've got the undefined. Pi over 6 is closer. Notice pi over 6 is closer to 0 than it is pi over 2. So pi over 6 is going to be approximately here. And there's 2. Pi over 2 is 1. 5 pi over 6 is closer to pi than it is to pi over 2. 5 pi over 6 is going to be about here. And it also has a cosecant of 2. And then here, this is undefined at pi, so this is another asymptote. And then at 3 pi over 2, we're going to have -1, which is going to be hard to see. Let me make a purple dot so you can see it. There you go. And then at 2 pi, it's going to be undefined. So the shape, it looks a lot like a parabola, but it is not a parabola because parabolas extend forever in the x direction, and these are cut off by the asymptotes. You're going to have an up branch, and then over here you're going to have a down branch, and the down branch is going to have a similar shape to the up branch, it just goes down. So it looks like this. Oops, a little bit messy, but you get the idea. Okay, so when we graph cosecant normally, we don't go to the trouble of making this long table of values. We memorize the shape, and an easy way to memorize the shape is to graph sine. So remember, sine is midline up, midline down, midline, and you do that lightly and then you erase it later, but you know, it's going to be like around here. You do it really light. And then once you graph sine, you're going to notice everywhere where the sine hits the midline, your cosecant graph has an asymptote. So there's an asymptote here, here, and here. And where the sine has a maximum value, the cosecant shares that point, and then this curve that was curved downwards it flips up. So I like to say that I'm flipping the curve, which kind of goes along with the idea of reciprocal. The cosecant is the reciprocal of sine. So this part here that's concave down, it flips to be concave up. And this part here that's concave up, it flips to be concave down. So that when you draw your cosecant and your secant graphs, you don't always have to make a table of values. You can just draw your helper function. Helper function for cosecant is sine, and then flip your curves. The domain is tricky, so I'm going to do that one second. We're going to do the range. So the range starts down here, pointing down to negative infinity, and it goes up to this value here, y is negative 1, and then there's a break. This red one, remember, is sine. That's not part of cosecant. So there's a break in the cosecant function until I get here, where the y is 1. And then it continues up to positive infinity. So that's your range. Your domain, it looks like this pattern will continue forever, just like sine and cosine continues forever, but we have to leave out these asymptotes. Now for cosecant, the asymptotes happen at 0 and 1 pi and 2 pi, and you probably guessed 3 pi and 4 pi and 5 pi. So those are all the asymptotes. So their domain is all real numbers, except x cannot equal any multiple of pi. So we say pi times k, and k could be 1 or 2 or 3. So x cannot equal 1 pi, x cannot equal 2 pi, x cannot equal 3 pi, or even negative. X can't equal negative pi or negative 2 pi. So the way that we want to include all of those is by saying k has to be an integer. So k could be 1 or 2 or 3 or even a negative integer. And so you say k is an integer. And that might sound familiar from when you graphed tangent and cotangent. Alright, so if you are ready, you can move on to secant, and if you're not ready, then you can pause the video to spend some more time with that one. Alright, I believe that, let's see. Now we can see the secant graph here. So the secant, remember, is the reciprocal of the cosine. And I didn't choose as many values this time because you got the idea of the shape. So I just chose 5 key points at the same 5 key points as cosine has. So the reciprocal, when your angle is 0, you're looking at the x value. The reciprocal of 1 is 1 over 1, which is 1. And at pi over 2, looking at the x value, reciprocal of 0, 1 over 0 is undefined. When we get back to pi, reciprocal of negative 1, 1 over negative 1 is negative 1. 3 pi over 2, reciprocal of 0, 1 over 0 is undefined. And at 2 pi, reciprocal of 1 again is 1. So you're going to see something similar to when you graphed the cosecant. Again, I'm going to graph my, label my axes, negative 1 and 1, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so at 0 we have 1, then we get undefined, then we have negative 1, and then we have undefined. So this graph is similar to the cosecant graph, but it's hard to see a full period of this graph when you graph just 0 to 2 pi. It is a full period. It just doesn't look like it. Let's see, and at 2 pi, what did we have? We had 1. So you still have a down branch, and you have 2 halves of the up branch, which makes a full up branch. So one period of this graph is the down branch and the up branch. That makes a full period. So the period of secant is 2 pi. The period of cosecant is 2 pi. But some people like to continue graphing this. So you could continue over here, and maybe I'll just use another color so you can see what it would look like. So if I continue graphing over here, then you can see a full up branch. People just like to see that for some reason. And then over here, you go down, and then you would have another asymptote. So this continues over and over again, just like you would expect, and it's fine to just graph the 2 half up branches and the full down branch, but if you want to keep graphing too, that's fine. So your range is the same range as your cosecant, negative infinity to 1, and then 1 to positive infinity, negative infinity to 1, 1 to positive infinity. And your domain is similar to your domain of cosecant. It's all of the numbers except not the asymptotes. But this time the asymptotes are a little bit trickier to describe. So we're going to say all real numbers except x can't equal. It can't equal pi over 2. But I can't say pi over 2k because that would mean 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. It would give me too many asymptotes. So I'm going to say x cannot equal pi over 2 plus, every time I add pi to pi over 2, I get another asymptote. So plus pi k, and k is an integer. Okay, so if you're ready, you can move on, and if you need a minute, you can pause the video to make sure you got all that. Remember that secant also has a helper function, so when we graph secant later, we're not going to graph a table of values. What we're going to do is we're going to graph cosine. So remember, cosine is up, midline, down, midline, up. And wherever cosine hits the midline, you get an asymptote for secant. And then whenever cosine is up, you're going to flip that curve, and whenever cosine is down, you're going to flip that curve. So that's going to help us draw our secant without making a table of values. When you want to transform secant and cosecant, the method is just transform the sine or cosine, and then we're going to flip our curves. It's pretty easy. So remember that for cosecant, your helper function is sine, and I want to shift my sine to the right, pi over 2. So my graph would start over here at pi over 2, pi, 3 pi over 2, 2 pi, and since I'm shifting everything to the right, I might want to make one more line right here, and that would be, let's see, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, this is going to be 5 pi over 2. 1 and negative 1. Alright, so then I'm going to graph really lightly. Let's see, maybe I'll try the yellow. I'm going to graph the sine. So the sine would start at pi over 2, and then it would go up, back to the midline, down, back to the midline. So that's my sine. Shifted to the right, pi over 2. So then, to graph the cosecant, everywhere where my sine hits the midline, I get an asymptote here, because the reciprocal of 0 is undefined. Okay, and then this maximum value is shared by the cosecant, and you flip your curve, so it's going to go like that. It's going to go like that. Now remember, the behavior of graphs near a vertical asymptote is that it's going to get closer and closer to that graph. So the way this graph is tilting in a little bit, that's not super. It should be getting closer and closer. I'm going to try harder on this side. Get closer and closer to your asymptote. Closer and closer to your asymptote. And of course you can continue the pattern by drawing more branches over here. Your range did not change because we didn't shift it up or down. So your range is still negative infinity to negative 1 and 1 to infinity. Your domain is all real numbers. X does not equal. And we have a first asymptote at pi over 2 plus the distance between these asymptotes is a distance of pi. If I subtracted 3 pi over 2 minus pi over 2, I would get pi. So that goes here, plus pi k. And k is an integer. Okay, next page. Okay, there's a lot more going on in this graph, but remember that your helper function is going to be cosine. So we want to figure out the period. The period is going to be 2 pi divided by b, so 2 pi over 2, which is pi. So I'm going to put pi on the fourth line. 1, 2, 3, 4, that's pi. That means that's going to be half of it, and half of a half pi is 1/4 pi. So pi over 4, 2 pi over 4, 3 pi over 4. I'm going to be shifting to the left pi over 2, so I need to label some over here too. Negative pi over 4, negative pi over 2. The up one is going to put us up here. And that's my midline. And then I want to label, I didn't change my amplitude, so I need to make sure I get 2 and 1, and this is 0, of course. So I'm going to graph cosine. I like the yellow, so I'm going to go with the yellow. The cosine is going to start to the left, pi over 2, and it's going to start one above the midline. So up, midline, down, midline, up, and here's my cosine curve. So everywhere cosine hits the midline, you're going to make an asymptote. And then you want to flip your curves. So this minimum point flips. This maximum point flips. And you can continue the pattern if you like. Your domain is going to be all real numbers. X does not equal. We have one asymptote at pi over 4 plus the distance between these asymptotes is going to be pi over 4 and another pi over 4, which makes 2 pi over 4, which is pi over 2. Okay. My range changed, so my range is negative infinity to 0. And then up here 2 to infinity. Okay. Here is a cosecant. The helper for cosecant is sine. We didn't change the period, so I'm going to have 2 pi and pi, pi over 2, and 3 pi over 2. I did shift left pi, so let me go this direction. Negative pi over 2 and negative pi, just pi. Negative pi. Okay, and let's see, I have an amplitude of 3. So 1, 2, 3. Alright, so sine is the helper function, and sine's going to go midline, up, midline, down, midline. And then the cosecant will have an asymptote where sine hit the midline. And I'm going to flip the curves. Okay, and ask me the shifts here. I don't remember it asking me the shifts before. Nope, it didn't. So it had a phase shift or horizontal shift. So phase shift, left, and that went left pi. Domain and range. So my range is negative infinity to negative 3 and 3 to infinity. And then my domain is everything except for 0, pi, 2 pi, 3 pi. So that's the slightly easier one. All real numbers. X does not equal pi k. And of course, k is an integer. Alright, in number 6, there's a hint. Remember to factor out the b value first. So if this 2 is not factored out yet, like it was factored out, let's see, up here, you can see the 2 was factored out. We need to do that work. So all you have to do is divide each of these by 2 to factor it out. So we'll have 1.5 secant 2, and that's going to be just x minus, and if I divide this by 2 I get pi over 2 minus 1. My helper function for secant is cosine. So I'm going to start labeling. I need to go down 1 to -1 for my midline. So let me put in a few more numbers. And then I need to go right pi over 2. So my graph's going to start there. Oh, but before I label that, I need to figure out my period. Okay, so the period is 2 pi divided by 2, my b value, which is pi. So my fourth line is going to be pi, and then this is going to be pi over 2, pi over 4, and 3 pi over 4. My midline is down at -1. Okay, and I'm shifting to the right pi over 2. So cosine would shift right pi over 2, and it would start 1.5 above the midline. So up midline and then down 1.5. Now I know I could put another one on the midline up here, somewhere around here, but I feel like I'd like to have at least 5 points, so I'm going to have to go backwards to make my last point. So I'm going to go backwards to the midline. So that's, oh, that looks like a sign. It looks like a sign because I put the extra point there, but remember that my actual start point was this one. So that's my start point, and that's how I'm calling it a cosine graph, because cosine starts up. And I wanted to make sure I had 5 points so that I could have a full graph. So then I need to put in my asymptotes. So I have asymptotes everywhere where my graph crosses the midline. And then I'm going to take my maximum point and flip here and here, here, and here. Alright, so that should be my secant graph. Now my shifts, I had 2 of them. I went right pi over 2 and I went down 1. So it was phase shift, I'm going to do PS. So phase shift right pi over 2, and then I'm going to have a vertical shift down 1. Those are my shifts. My range is -infinity up to, let's see, it looks like -2.5, and then 0.5 to infinity. -infinity to -2.5, and then 0.5 to infinity. And my domain is not pi over 4, and then I need to know the distance between these two. So that would be pi over 4 to pi over 4, which simplifies to pi over 2. So my first asymptote is going to be x is equal to all real numbers, or x is an element of all real numbers, but it does not equal pi over 4 plus pi over 2k. Does not equal pi over 4 plus pi over 2k. K is an integer. Alright, so if you have all of that, you're done. You're ready for class tomorrow. If you don't, you might want to go back and go over those notes again.